Today we're going to look at section 6.3, which is matrices. Now, matrices are just inordinately powerful. These are little buggers that can contain so much data, and you can do so much data analysis and so much data manipulation with matrices. It's completely ridiculous. And this is something that no one ever explained to me when I was taking matrices. I just thought we were, putting numbers in rows and columns for funsies. But there's actually some really seriously awesome applications for this kind of work. So to get started, let's talk about what a matrix actually is. So we can say a matrix is data. Almost always is data arranged in rows and columns. Okay? So you'll have something like, say that's not what I wanted to do. Say I've got some information. We have test 1, and I have test 2, and I have student A, student B, and student C. Now I could say, well, the first student got a 96 on the first test, the second student got an 86, and the third student got a 73. The first student got a, what do we say? We'll say a 92 on the second test. The second student got a 92, and the third student got an 88. All right? So this is like a table, right? Well, what I can do is I can take this information and I can put it in matrix form. Now, your book uses brackets, so we'll try to do that for a little bit. So 96, 86, 73, 92, 92, and 88. So this is an example of a matrix. I've taken the data that I have and I've put it in a matrix. The reason we put data in matrices is because when we do that, now all of a sudden we can feed that information into a computer in a way that we couldn't before. And the computer can process this information, and we could find an average, or we could find an average per student, or an average per test. We can do all kinds of things with it now that we have the information in a form of a matrix. So these are called columns. These are the columns. So this is a column, this is a column, and this is a column. And these are the rows. These are the rows, and then those are the columns. So this particular matrix has 2 rows, and it has 3 columns. And this is how we kind of keep the data organized. Now, we can have other kinds of applications for matrices besides this. Matrices, we can use it just in general for organizing data on a large scale. Okay? So if you've ever gone to Google Maps, for example, and you say, how do I get from here to here? Now, Google Maps doesn't actually go in and measure how far it takes, to get from, this is a terrible Texas already, from Abilene to Waco to Houston to Dallas, for example. It's not going to actually go in there and use a ruler and measure it, this way and this way or whatever. It's going to have a table with information, and that table is going to be in the form of a matrix. I'm going to get rid of my absolutely appalling graphic art here. So what you can do is, if you have this information in a matrix, you can process it, you can find shortest paths. There's this famous problem called the Santa Claus problem, which is basically, now you want to see me draw the United States. It looks something like this, and there's Texas, and that's the United States. And the idea is, well, if Santa has to visit every single town that has at least 500 people, what is the shortest path that Santa could take and would get to all the different towns in the United States? And this is a problem that's actually almost impossible to solve with absolute certainty. But this kind of information you would store in a matrix, and if you become very, very sophisticated with matrices, you can solve this problem or come close to solving it in a very smart way. So the more you know about matrices, the easier it is for you to solve very, very complex problems like this. And so this is why we study matrices, is because if you go into sciences, this is something that you're definitely going to see again. In fact, if you do go further along in your math studies, you're going to take a class called linear algebra. And in linear algebra, it's all matrices. Okay? So, you know, for example, if I'm looking at that shortest path problem, I could say, well, I have Houston, and I have Waco, and Abilene, and Dallas. Now I could make a table that would say, all right, Houston to Houston, well, that's 0 miles. I can put that one in there. Waco to Waco is 0 miles. Abilene to Abilene is 0 miles. And Dallas to Dallas is 0 miles. But Houston to Waco is 190. Houston to Abilene is 349. Dallas to Houston is 242. Waco to Abilene is 185. Waco to Dallas is 98. Abilene to Dallas is 184. So I can actually go in here and I can fill in a matrix. So I can keep this information stored as a table. But whenever I plug this into a computer, actually the most effective way to do this would be to create a matrix, which just has the data in it without the titles. So I can plug this in here like this. Now, I'm not going to be solving any shortest path problems for you, and you're not going to be solving any either, but I do want to motivate the study and make sure you understand that, or help you to understand that the reason we're studying this is not just because it's fun and we do stuff with it, but I mean, these are like some significant problems that are solved, you know, so whenever the post office or UPS promises 5-day delivery or 3-day delivery, you know, they have to find the shortest route to go between various places. And gosh, there are applications with like cruise scheduling problems on airlines. So, you know, crews can only be scheduled X number of hours in a, 40-hour period, and then they can only fly this many miles, and they need at least this much time between flights. How do you solve this huge problem and get all the crews optimized and organized the best way? And the way that we do that is by studying matrices. So let's again look at what we have here. We've got columns. These are our columns. Columns. These are our rows. All right. So if we count, we have 4 rows and 4 columns. Now make sure you got this down. In matrices, when we're talking about matrices, we always talk about, I can't spell always, we always refer to rows first and then columns. Okay, rows first and then columns. So this is important. So whenever we actually talk about, let me give you a definition here. When we talk about matrices on a fundamental level, we have to talk about how big they are. Your book uses the word order for the order of a matrix. Later on, you'll just call it the size of a matrix. Okay, the order of a matrix or the size of a matrix. The order of a matrix, or the size of a matrix, is always written like this. The number of rows, and then X number of columns. And whenever we have the X, we say the word by. So like if you have a 2x4, it's not actually 2 inches by 4 inches, but you call a piece of wood, you call it a 2x4. That's how wide it is by how long it is. That's not exactly right, not long. That's how wide it is by how tall it is. Rows by columns, 2 by 4. Again, just to keep things straight, we always talk about the rows first and then the columns. So if you're looking at a matrix, we're going to go rows, so we count the number of rows, and then we go columns, so we're going to count the number of columns. Rows by columns, so always go down and then over. Rows columns. Okay, so let's just look at a couple of examples here. Say we want to find the order. Or again, I'm going to revert and call it size because that's what I call it in every other thing that I do besides this book. So if I say order, please understand that I mean, if I say size, please understand that I mean order. And when your book says order, when your homework says order, say, oh, that's the size that she was talking about. Find the order or the size of each matrix. Okay. So remember, it's the number of rows by the number of columns. Okay, so let's look at this one. Try, I'm just going to do this. Say we have 1, 6, 3, 0, 5, 2. So if I want to know, well, how big is this? What's the size? What's the order of this matrix? I'm going to say, okay, I'm going to go down. I'm going to go down. Hey, try again. You toot. Why are you doing that? There we go. There we go. Down. All right, so I've got 1, 2 going down, so it's a 2 by, and then going across, we have 1, 2, 3, so it's a 2 by 3. It's a 2 by 3. A 2 by 3 matrix. Let's try another one. Now, I'll get there in a second. I don't want to give you too many things at once. I get so excited. I really love matrices. So I'm likely to just start to ramble about them. So let's look at the size of this one. Now again, on the computer, try to pause it, see if you can come up with it on your own. So we're going to go down. It's a 2 by 2. It's a 2 by 2. Now, it's very, very important. A 3 by 2 does not mean the same thing as 2 by 3, right? Because a 3 by 2 has 1, 2, 3 rows, 1, 2, 3 rows, and 2 columns. A 2 by 3 has 2 rows and 3 columns, okay? So don't say, well, I got the right answers, I just got them in the wrong order. If you get them in the wrong order, it is the wrong answer, okay? So really make sure that you're following the order on these problems. So try a couple more. You put a couple more up here, and then you can pause it and see if you can get all of these put together and find the sizes for all of these different matrices. Some of these are tricky, but important. If you hear funny noises, it's because I'm having work done on my house, and it's all drilly and funny sounding. Okay, so if you will, pause it, try to work it out. Otherwise, we'll just go ahead and go forward. So these are all going to be a something by something. So we're always going to go down first. This is a 1, 2, 3. A 3 by 2. Okay, to get that. This is only a 1. Right? It's only 1 down, 1 row, and 1, 2, 3, 3 columns. 1 row, 3 columns. Let's go down. 1, 2, 3. 3 by 1. And it's a 1 by 1. Okay, so these are all the sizes. A 2 by 2, 3 by 2, 1 by 3, 3 by 1, and a 1 by 1. So you can have a 1 by 1 matrix. It's just a big old fancy matrix with just one old silly piece of data in it. So you see this is a 1 by 3 over here. This is a 3 by 1. So again, you can't just put them in the wrong order and say, well, I'm mostly right, I just got that one part wrong, because that's a really, really big part to get wrong. Okay? So let's take a look at some of these matrices again. I'm just going to rewrite them so we're pretty and we have them to look at. Let me just rewrite this first one. Now, I'm going to stop doing this bracket thing because it's very annoying to write, and I'm just going to use parentheses, but they mean the same thing. 1, 6, 3, 0, 5, 2. It's just faster than to go like this every time, and it's ugly. So, I'm just going to do that. When we refer to an element of a matrix, if I want to talk about a specific element, say I wanted to talk about this 1. So how do I refer to the 1? As I say, well, it's in the matrix A, except I'm going to use a little a. I'm going to say it's in the first row and the first column. Sometimes we'll put a comma in there. I don't think your book does, but I'm going to say it's in the first row and the first column. So again, we always refer to the row first and then the column. So I could say A in the first row and the first column is 1. Now's probably the time to mention you've probably noticed that all of our matrices have been capital letters. And that's because whenever we talk about the elements in a matrix, we want to use a small letter. So if I say, well, what is A2, 1? So I say, okay, well, what's in the second row, column 1? All right, so I'm going to look at my matrix. I'm going to say first row, second row, column 1. So second row, column 1, that's element 0. Okay, now I know you can't erase, so your paper is probably going to be slightly less beautiful than mine, but that's just a hazard of the trade. All right, so let's look at A2, comma 3 and say, well, where is this? We'll say, well, A2. This is going to be the row, and this is going to be the column. So we're looking at the second row and the 1, 2, 3, the third column. Second row, third column, and they intersect here at the 2. Okay? So you're going to probably have 1 or 2 problems where you're trying to find what these values are and how to find them. What if I asked you for A3, comma 2? And I say, well, that means I'm looking for the third row and the second column. Well, I look up at my A up here. Is there a third row? No, there's no third row. So this would be kind of a trick question. Doesn't exist. There is no A3, comma 2. But there is a 2, comma 3, right? 2, comma 3 was 2. 3, comma 2 doesn't exist. Okay, so it is very, very important that you always remember we first start with our rows and then our columns, because if you get them out of order, it's just going to be inordinately terrible.